now we've gotten a successor. And I'm using the word successor, maybe not as best as I could, because that doesn't mean that machine learning model or the machine learning is not being able to, or is not being used anymore. So now we've got deep learning. So remember, we're speaking about artificial intelligence. Then within artificial intelligence, we've got machine learning. Now, when we dive deeper into machine learning, we get now what we call deep learning. Okay, so deep learning, within deep learning, what these AI architectures of AI engineers have been able to replicate is the way the human brain works. So the central neural network system, they've been able to duplicate that. And what we see here is what the process of deep learning looks like. Okay, so for those of us that are maybe quite keen in terms of neurobiology, and how the brain works, as we know, we've got neurons. Okay, and these neurons receive information, and then think of that as the input layer. So it's receiving data. Okay, and I want to make, once again, this analogy. So you're receiving data, and what is the data? The data is learner marks. Okay, so you're receiving learner marks. Now, when we come to the hidden layer, this is when the actual processing of that data is taking place. So think of the hidden layer, as an educator, as a facilitator's mind, looking at these marks, trying to understand the outcomes, and also trying to see type of connections. So what is the connection? So if there's high marks, what's the connections happening there? If there's low marks, what's the type of connections happening there? And then finally, you think that the output is like the final mark you're going to give your learner, or the final thoughts, or the decision that you are making. And I think this is very important, especially I think, when we look at it, especially if we have any educators on the call here that are currently teaching, especially when it comes to the type of end of year, and you're thinking in terms of progression time. So you have maybe this particular learner. So you're inputting its data, so it's thoughts, okay, how this data, how this learner's marks are looking. So it might not be the best marks, okay? But now you start to process in the hidden layer behind this, behind the scene. You're starting to think in terms of, okay, but Lionel is such a learner. He's in school every day. He's trying his best. His homework is done. He might not be very book smart, but he's quite dedicated. And it's been a pleasure to have him or her in my classroom, so I can see the potential. And then you actually decide, okay, I'm going to let this learner progress. Okay, so I'm just using a type of analogy in terms of a real world classroom setting for us, just to understand what the deep learning aspect looks like. And because of deep learning, we've now been able to create what we call generative AI tools. And generative AI tools like ChatGPT, Gemini, Canva AI tools, and then also DALL-E, which is the picture generating system or component of generative AI. Okay, so let's look at the live demo of prompt engineering using generative AI large language model. Okay, so prompt example, create a grade 8 STEM club activity. Are there any of you here running after school clubs, perhaps? Just by a show of hand. Okay, perfect. We just move that over. Okay, perfect. Okay, so a lesson plan for a grade 8 STEM activity. Okay. Just off the top of your head, maybe, and just maybe in the chat box, how long does it usually take you to design your lesson or your activity using traditional methods? I'd love to hear from the floor. Wonderful, Tapelo. 30 minutes. Okay. Any others? Yeah, 45 minutes. Okay, so anything between 30 minutes, 45 minutes, depending. Okay. But I don't think it's anything like below 30 minutes. I'll be talking about like a well set out lesson plan, okay, or activity plan. So I'm just popping into ChatGPT, which is a generative large language model lesson plan for grade 8 STEM activity. Okay, if I can even do a countdown, 5, 4, 3, 2, 1. So we've got in a couple of seconds, we now have an entire lesson plan built out for us um, in mere seconds. So I'm gonna run with the 30-minute answer from Tapela. So a task that took me 30 minutes, I now can achieve within 1 minute, giving me 29 minutes more to focus on either it is on planning how I'm going to facilitate this, how I read through the lesson plan, or prep another activity. Okay, so let's see. Lesson plan building a balloon powered car. Level grade 8, subject science, technology, engineering, and maths. Duration of the lesson 60 minutes. I've got my objectives. I've got the materials that I need. Sorry, Margaret. Your camera is on. Maybe you want to maybe just switch off your camera. Thank you. Um, Key STEM concepts, and there you've got your lesson plan. So once again, 30-minute task broken up into a couple of minutes, and that's the power of prompt engineering. And I think, especially to your comment, Mark, as we can see now, the type of correlation and the way in which we could leverage artificial intelligence in education to further enhance um, our teaching and our learning. Okay, so let's think what is prompt engineering? What's it all about? Okay, maybe just one or two answers quickly from the flow in terms of how you would articulate prompt engineering. I believe probably 90% of the group here has obviously created a prompt, popped it into whether it be ChatGPT, Gemini, Copilot, and they've gotten some feedback, instruction input. Perfect. Nice. Anyone else? Okay. So definitely instruction input, and that's one aspect of prompt engineering. Prompt engineering, it's broken down is and it's very intentional in terms of probably the naming as well, because when I'm thinking about engineering, I'm thinking about different parts, how it comes together, and planning it to build something. So when I'm thinking about engineering, I'm thinking about building, whether it be civil engineering, graphics engineering, mechanical engineering, electrical engineering. It's all about building sustainable things that last, stability. So engineer can probably around on all about the word engineering. So let's look at um, a defined explanation or definition of prompt engineering. So prompt engineering is the art and science Oh, very fancy. It's the art and science. So prompt engineering is instruction input, but it's also so much more. Okay, so it's the art and science of designing and optimizing prompts to guide AI models. Okay, so remember, in prompt engineering, the power lies within your hand. So the output or the quality of the output doesn't rest with the type of AI model that you're using, whether it's Copilot, whether it's Gemini, but it rests with your understanding of prompt engineering and how to build your prompts. So, optimizing your prompts to guide AI models, particularly large language models, and that's part of the NLP family, the natural language processing, but we're not going to get into that today. So particularly LLMs towards generating the desired response. So when we look at it, AI doesn't know what you want, what you're looking for. And AI also has at its disposal a vast variety of information at its disposal. So vague prompts, vague output. Okay. Well defined prompts, very, very nice and precise output. Okay. So let's look at some of the makeup um, of prompt engineering. Okay. So we've got the prompt in itself. Okay. Precisely formulated inputs given to AI language models. Okay. Um, and you'll hear LLMs of small language models used, especially in the sphere of AI, and that's because of deep learning's ability to process human language and understand it as it's spoken or as it's written. Okay, you need to give it some good context. So there needs to be context in your prompt. So it's your prompt, you have your context, and also be conscious in terms of your tokens. Okay. So for those of us using free versions of Copilot, you'll see that sometimes, based on how often you use your model, and if it's free, it will indicate you that look, all your tokens, it's up. You need to wait for a set time period for it to be refreshed. It's all about fine tuning and also then just obviously priming, adding additional context to your prompt. Okay. So for prompt engineering, there are best practices that we use when we really engage with our large language models. Okay. So firstly, it's all about being specific. Um, what you want. So remember our prompt about the grade 8 STEM activity. So it gave us some good output, but that output could have been generated way better and much more precisely. So remember, we work within South Africa, we've worked in different contexts. Um, so we need to take into consideration when we're drafting prompts for lesson plans to take into consideration also our participants, the beneficiaries that we engage with, what resources we have at our disposal, what's our infrastructure in terms of ICT, what that looks like, and also what we are trying to achieve with that. Let's look, when just indicating STEM, that was a very broad um, topic there, but we need to be able to drill down. Okay, use examples. Okay, so I think when I was speaking to Zoe in the makeup of the session, we are speaking like initially when we started engaging with AI, we had like this one sentence prompts, but now the prompts look like a half a book in terms of how detailed it is. But the more you want out, the more you need to put in. Okay, set the context, set the background, what things are looking like on the ground, and don't always take the first response if you are not happy with it. Prompt your AI model or your chatbot to give you a different variation in terms of it, and also limited scope. So back to the STEM subject there. So look, STEM, science, technology, engineering, mathematics, that's very broad. If we could have honed in um, on that, saying, look, it's technology. We're busy with circuits. Can you please design me something nice? I've got maybe 2 or 3 batteries and 1 or 2 grids with a class of 20 people. How can I really create a lesson plan that will be fun and engaging for learners aging from um, this age group? Yeah. So very important to limit the scope so that AI doesn't overload you with a lot of unnecessary information. Okay. And then also test your approaches. So you have your time. Try one method, try the other method, and see really what's going to work best for you. So when we think about it, and we were thinking about prompt engineering, I'm just speaking to AI, just asking a simple question. It's much more intricate than that. And it's so because of the wealth of information AI can access and has already at its disposal. Okay, so let's look at an example from. So you and after school facilitator create a fun coding activity for 12-year-olds with no prior experience. So, what do you think of this prompt in comparison to the initial prompt that we started with? You can just give some of your context or comments in the chat bot, or you can really start to maybe then just engage verbally. Because I just really just love to get your thoughts in terms of how your thought processes now is just when you're going to engage with your AI model that's at your disposal. Okay, different, not detailed enough. Perfect. More specific to the detail. Perfect. And maybe then just now, in terms of your understanding, maybe um when thinking of how we engage with AI, do we have any talkers? Mm.
Yeah, happy to chat.
Ah, perfect.
So, I think there's so much information, as you've been saying, in terms of the data pool to select information from,
Mm.
that unless you properly understand what it is that you're wanting to achieve, you can't expect a machine to give you the answer that maybe you're not even expecting if you don't instruct it properly. So, in your example here, um, okay, great. We know who you are. We
Mm.
know that you want to create a fun activity for 12-year-olds who have no experience, but an activity regarding what? Do the 12-year-olds know how to read? Do they know how to read for meaning, which we know is a problem in South Africa? Is it a maths issue? Is it a science thing that you want to create? So there's just absolutely not enough information for you to build anything that's of value without instructing it properly.
Perfect. So now we're actually starting to look at prompts much more critically from a critical type of thinking mindset of hat that I'm now starting to wear. And this is what I'm quite happy with because and I'm reading the comments in the chat bot of index. I'm getting the tongue twister between chatbot and chat box. So the initial prompt was a one-liner. So this prompt's about the type of three-liner based in terms of my screen size. But yet we can still build, though this prompt has a bit more context than our previous prompt. There are still a few things or a number of things that we're missing out. So we're really starting to think about our prompts more critically now in terms of, as you said, Mark, what I want to achieve, what's the context that I'm working, what's the background, what's the reading efficiencies of my learner. So this could be a coding activity, this could be a mathematics activity, this could be a reading activity. So really, when we think about prompt engineering and our role as educators, as facilitators, as after school practitioners, we're really starting to see the power or the ability of AI, but now also starting to see our responsibility as the users. So the more I am a bit clued up and understand the components and the intricacies of AI and its prompting per se, and focusing on that, especially for this session, I now get to see the importance of really having that type of bit more, spending a minute or two on your prompt a bit more longer. And now back to my comment that I've made between myself and Zoe. So now your prompts are not just that one line of prompts, but it's really two to three lines, even a paragraph. So the better information you put in, the better information you are going to get out. Okay. So now I just want to give the flow an opportunity to for the next 10 minutes perhaps, because I see we are going to have enough time for you now to go onto your model that you are using. So here we've got a science lesson, a creative arts activity, a leadership activity. And I want you really to take the time to really think about your prompt, and also try and use different type of prompting styles for the three lessons. So whether it be the science lesson, and that's going to be, you're just going to use a vague, your old school prompting style. For the creativity, you're going to give a bit of more context, and for the leadership, and then you can also just see the different level in terms of the engagement, or even use one lesson and then prompt it in three different styles, and then just see the output. And then we're going to come back here about half past, so nobody's going to leave the room, but I just want to give you some time. I'll put up a 10-minute clock countdown on the screen for you to engage with your whether it be GPT, Gemini, and then hopefully we'll be able to get some good learnings out of that, because I really want also um, the flow or the group of individuals here to come and tell us what your findings were, so that we can start to also learn from one another, and also to see what you found out and what you got from your models.